All right, today we're diving into something that's absolutely critical, network security in AWS. But let's forget all the complex diagrams for a minute. I want you to think about it like this. We're going to build a digital fortress, and I'm going to give you the blueprint to design the walls, post the guards, and keep your most valuable data safe and sound.
So let me just ask you this straight up. Right now, is your cloud application an open door just waiting for anyone to walk in? Or is it a locked down, reinforced fortress? And hey, if you're not 100% sure about the answer, you are in exactly the right place. By the time we're done here, you'll have everything you need to build that fortress. Let's get into it.
You know, every great fortress needs a plot of land to be built on, right? Well, in the AWS cloud, that land is your virtual private cloud, or VPC. This is literally the ground floor, the foundation of everything we are about to build. So think of a VPC as your own private, fenced-off piece of the massive AWS world. The key phrase here is logically isolated. What that really means is you get total control over this virtual network environment. You decide who gets in, who gets out, and what can talk to what inside its walls. It is your own private digital real estate. Okay, so we've got our land. Now it's time to build our defenses. And look, a good fortress never ever relies on just a single wall. It uses layers, defense and depth. In AWS, our two main layers are network ACLs and security groups. So let's break down how they work together. Let's really dig into these two because they're different. Network ACLs, as you can see, are like the fortress's big outer wall. They guard entire neighborhoods or subnets, and they have really strict allow and deny lists. They're also what we call stateless, which is just a fancy way of saying they have a terrible memory. They don't remember who they let in, so you need a rule for traffic coming in and another for traffic going out. Now, security groups, they're more like personal bodyguards standing right next to each server. They are stateful, so if they let a request in, they automatically know to let the answer back out. Super convenient. They also only use allow rules, which makes them way simpler and much more precise for locking down your actual applications. Theory is great and all, but let's make this real. We're going to take these ideas and apply them to a classic 3-tier web application. This is the blueprint. This is how you put those walls and guards into practice in the real world.
So here it is. This is the only path that traffic should ever take. A user from the internet hits our web tier. That's the front door, usually an application load balancer. That web tier then passes the request to the app tier, which is where all the real work happens. And finally, the app tier talks to the database tier to get or save data. Our whole job is to enforce only this flow and block absolutely everything else.
So how do we actually do that? Well, it starts with public and private subnets. The only thing that needs to be visible to the public internet is our load balancer, so that's what sits in the public subnet. Everything else, our application servers, and especially our databases, they get to hide away in private subnets. They're completely invisible and inaccessible from the outside world. I mean, this is a massive security win right from the get-go. And all of this leads us to the single most important, the golden rule of all of security. It's called the principle of least privilege. And the philosophy is incredibly simple. You grant only the absolute minimum permissions needed for something to do its job and nothing more. And this right here, this is a perfect illustration of that principle in action. Just look at the security group for our application tier. The rule is so specific. It only allows traffic on port 8080. And look at the source. It's not the entire internet. The source is the security group of our web tier. That means only the load balancer is allowed to talk to the app servers. Nobody else. This is a perfect, minimal, least privilege rule. It's airtight, and you do the exact same thing for your database. Its security group would only allow traffic from the apps tier security group. Of course, building walls is one thing, but you also need to see what's happening at your gates, right? You need guards in the watchtower. That's exactly what VPC flow logs are for. When you turn these on, you get a detailed record of all the IP traffic that's being accepted or rejected by your network. This is absolutely essential for troubleshooting issues and, more importantly, for investigating any security incidents. Okay, we've designed our fortress. It's looking pretty good. But, even the best designed fortresses can fall if somebody just leaves a gate wide open. So now, let's talk about the 3 most common and, frankly, most dangerous mistakes that lead to security breaches.
First up, breach number 1. I call this one the unlocked front gate. This happens when you open up a management port, like SSH for Linux or RDP for Windows, to the entire world. That's exactly what that 0.0.0/0 means. Anyone, from anywhere.
You might think, oh, it's just for a minute.
But this simple mistake puts a giant, flashing neon target on your server. There are automated bots constantly scanning the entire internet for these open ports, just rattling doorknobs, waiting for an unlocked door. The fix is so simple. Lock it down. Only allow access from an IP address you trust and control, like your office network or a dedicated secure server.
All right. Next up is breach number 2, the exposed crown jewels. This is the truly disastrous mistake of putting your database in a public subnet, or even worse, giving it a security group rule that allows access from the internet. Let me be completely 100% clear on this. There is almost never a valid reason for your database to be directly accessible from the public internet. It holds your most valuable data. It should only, and I mean only, accept connections from your application tier, which is itself protected by its own security group. Anything else is just an unacceptable risk, period. And finally, breach number 3, what I like to call one giant key. This is the lazy approach. It's when you create one big, super permissive security group, allowing all sorts of traffic, and then you just slap that same group onto your web servers, your app servers, and your database. Doing this just completely demolishes the entire point of having layered defenses. Think about it. If an attacker manages to break into just one of your web servers, they now have a wide-open superhighway network path to move sideways and attack your application servers and even your database. By using separate, specific security groups for each tier, you're creating internal firewalls that can contain a breach if one ever happens.
So, we've talked about the fortress walls, the guards, and the common ways that attackers can sneak in. You know, it really all comes back to one master key, the single most important principle that governs all of this. And this is it, the principle of least privilege. This is your master key to security. Every single time you write a security group rule, every time you design a subnet, just ask yourself this one question. Am I giving this thing the absolute bare minimum permission it needs to function? If the answer is no, or even maybe, you need to tighten it up.
So I'm going to leave you with this one question to take back with you. Look at your own cloud environment and be honest with yourself. If an attacker managed to get past one of your security layers, would the next one actually stop them? Or would your whole fortress just crumble? Build your defenses in layers, and you'll build something that lasts.